for that period. And then
They do that too, but then the teacher's like, oh, I didn't check my email.
I have a question. So, if I was yesterday, like on like page 9, when it was like negative 3x squared plus 4a squared or something like that, could you do difference? Is that when you would do like difference of squared?
Yes.
Okay.
Sorry.
There's a college meeting this year, is that, alright.
Yeah. So we're going to apply the limit definition. I prefer the one with the A's in it, not the H's. And all right, whether you know it or not, you do too. The only time people don't know that they prefer one method over the other is when they just haven't used the other method. And in all honesty, people who look at what I'm about to show you here and say, oh, that's terrible, I hate that, I don't ever want to do that again. They just don't know how much worse it could be using the other limit definition. So you know. You don't have to love it, but you shouldn't hate it. You know, be nice to it, that's all. You can be polite. Not asking you to marry it. All right, so what am I doing here?
You're doing
The opposite thing.
Conjugate.
Hey, it almost doesn't even matter what it's called, right? Yeah, it's the conjugate. Right. Regardless of what it's called, as long as you know to do it, you're in good shape. How do we know to do something like that? Because I just did it, and you figured you'll just do what I do.
There's a wrong.
Because there's a radical, but more than that. In the numerator. Oh, yeah, I'll get that in a second. But my question. There is a radical, but what about the radicals?
It's annoying. We don't know what to do. I don't.
So you can cross something out.
Well, it'll help. It'll help us get the answer. True.
It's in the numerator?
To help
It's in the numerator, but am I looking at a single
It's a
radical?
different.
It's
two
a difference of
radicals.
radicals. If you have a sum or difference of radicals, that's when conjugates come into play. All right, that's the key to it. And knowing that that's the relationship will help you to be able to handle something like this down the line when you have to do it on your own. You know, see, over the years, way too many people copying down my answer key and saying, "Oh yeah, I get it." But like, you're just getting what I wrote down. You didn't generate the thought yourself. If you generated it yourself and you get it, that's even better. I mean, that's what we want. But if you're just looking at my work and saying, "Oh, that makes sense," that's good. But during a test, I'm not going to provide you with my answer key and ask you to critique it. So you want to get to a point where you're looking at this and saying, "Right, what is it about this fraction that's telling me to do that?" That's the thinking that comes into play. I'm not going to make you write a journal entry or anything like that, but these are things these are thoughts that you want to have. So when you're having your conversations in small groups, these are the things that you should be talking about. Like, how did I know that was going to turn into that without doing all this work? You know, that kind of stuff. All right. It was very inspirational. You're welcome. Yeah, later on in the course, you'll know when you're supposed to have been inspired and when not. For now, you probably don't know. That you were supposed to be very inspired by what it is. Anyway, so on the top, when I use what process? Multiplication, but specifically foiling or distributive property, we will then get something that will be sans the radicals. Basically, they cancel away. So that's too bright, right? I'm going to go for it. Sorry, it's 4x minus 5. I know it's like bright green, but all right, and then we have a 4a minus 5. All right, but that's being subtracted from the 4x minus 5. The outers and inners will cancel out. That's the whole point behind using conjugates. I mean, the good news is you won't have to deal with complex conjugates in this course. Those are the ones with imaginary numbers, but conjugates are still a thing and they're a useful resource. And they're a great way to stay in shape. Nothing. Cool. Okay, so movie references we don't get, Family Guy references we don't get. I mean, all my South Park references, I never expected that you'd get them because, I mean, it's not that popular anymore, but I don't know. I mean, what's going to happen is I'm going to have to start quoting Shakespeare and see if you get that, or make historical references. I think that's probably when, you know, the line of demarcation between a young teacher and older teacher is when the pop culture references stop making sense. Okay, I get that. But then when you just give up on them. I don't want to give up on my pop culture references because that means I will have gotten old. So don't let that happen, folks. It'll be all your fault. It's dreadful. I am not inspired anymore. I'm depressed. All right, I'm factoring out a GCF on top. Although Family Guy isn't that popular anymore either, so maybe that's what it is. All right, so x minus a's cancel. That's the whole point. If you go through this entire process and you don't get some kind of x and a cancellation, then you done did it wrong. So we have this. And so now what I'm looking to do is apply the limit. And that's always what's going to happen once you get rid of the troublemaker. The troublemaker, again, is the thing that's making the fraction undefined when you apply the limit. So if I replace a with x here, it would have been 0 on the bottom of the fraction. That's no good. All right? By getting rid of that, now I have something that's way simpler. Well, way simpler. Simpler. But even more importantly, it's something that's substitutable. So I can replace the a with an x. So 4 over 4x minus 5 plus 4x minus 5. I'll allow it. We have 2 of those 4x minus 5s under the radical. 2 goes into 4 twice. And so we get f prime of x. That's our derivative. And that would be 2 over the root of 4x minus 5.
Is it okay that there's the radical in
Denominator?
Yeah.
Oh, yeah, totally. Yeah, that's so weird. There was never a problem with that. Your teacher was just lying. Yeah, like you can't have a radical in the bottom of a fraction. They were just trying to make it so that you were forced to learn how to move radicals from one part of a fraction to another. It's really just a skill. But there's never really anything wrong with it ever. Yeah, they just wanted you to be motivated so that they would tell you it's wrong to have it down there, and you never wanted to be wrong because you're like middle school students, and so you kind of bought in 2 years ago. Okay, so maybe you were sophomore.
If you were to use this derivative to find the slope of the tangent at a certain point, and it gave you undefined, does that mean that it just doesn't extend to that x value?
Yeah, it means that there is no meaningful derivative at that location. And that's actually going to lead us into what we're going to talk about next week, which is something called differentiability. When something is, when you're capable of finding the derivative versus when you're incapable. Right? So knowing where your derivative is undefined or imaginary is really important. All right, so what you're going to do